Hello and welcome back to the stream. We are talking fourth grade math, and in particular today, we are talking fractions, one of the great monsters of mathematics and often something that people struggle with all throughout their lives. This is one of the really big first stumbling points in math that really gets students confused and frustrated, and often this is the point where the wheels start coming off. So I'm going to try really hard through this series of videos to not only explain how fractions work, but hopefully demystify them a little bit so they're not quite so intimidating to students who haven't encountered them before. Beyond that, I do have some previous videos. If you look back at my third grade playlist, we talked a little bit about unit fractions and just a little bit about comparing fractions and what they represent. I also have two other videos, one called The Weird Number and one called The Linguistics of Mathematics, where I talk about numerator and denominator and why those names are what they are. I might recommend checking those out before getting started on this little mini-series that we have going. With that in mind, we are 42% of the way through fourth grade. So we're starting with equivalent fractions, fraction models. Let's go. Now, I really like these kinds of problems and these kinds of visualizations. I think they're really very important. And if you watch my previous videos, you'll see that I really like coming up with pictures. Yeah? I like being able to say, well, 1/4, the way you do 1/4 is you take some shape. I'm using a circle here, but the shape doesn't matter. You cut it into 4 equal pieces, equal-ish. Again, I'm not an artist. And then take one of those, and there is your 1/4. The top number 1 tells you how many pieces there are. The bottom number 4 tells you how much of each unit whole you're cutting away. So how much of one is each piece? Or better yet, how many pieces is each whole cut into? That's a better way of putting it. Okay. So in this case, we are looking at a couple of long, thin rectangles that have been broken also into fractions. Yes, on the top, we can see that it's been broken into 1, 2, 3, 4, 5, 6 equal-sized pieces, and the bottom, of course, is cut into 2 halves. The idea being, we want to be able to visually see, before we start talking about common denominators or multiplication or any of that nonsense, we need to be able to see visually that 1/2 is the equivalent of 1, where is it? 1, 2, that's not right. Still getting used to my new setup. 2, 3/6. This isn't magic, it's just observation. If you take 2 equal size, in this case rectangles, cut 1 into 6 equal pieces and 1 into 2 equal pieces, then the 3 from the one that you cut into 6 will match up equally with one of the halves on the other one. Really driving home that point is one of the reasons why I like Khan Academy's method here. 3 out of 6. So here we have how many eighths. Okay, we want to know how many eighths is 1/4. Yeah? And in fact, I believe they very helpfully down here show us that 1/4 is that right there. In fact, we used this example just a moment ago. 1/4, which means we can just match it up visually. Here is the same wedge on the one that is instead cut into 8, and we can just count that there are 2 eighths that are equivalent to 1/4. Really, you want to look at this visually instead of just jumping straight to the rules. So 2 eighths is the same as 1/4. Again, you could almost think of it like Well, if I have something cut into 4, which I do right down here, what would happen if I took that fourth and I cut it in half? And I did that with each of the others. Well, the number of pieces would double because I'm cutting each one in half, and each piece is now 1/8 instead of 1/4. Which picture has an area equivalent to 8/12 shaded? So let's see here. What we've got is 3/6. We've got 3/6 up here, yeah? We've got 3/4 down here, and we've got 2/3 here. Can you see why I'm able to say that? This is really the basis of why the word numerator and denominator are what they are. I say that that B up there is 3/4. 3 because there's 3 of them, 1, 2, 3, and fourths because each one of them is one of 4 equal pieces. Each one is a fourth. The numerator tells you how many, the denominator tells you how much each one is. Okay, but we're being asked which one of these is equivalent to 8/12. Well, let's see. If it was broken into sixes here, if I wanted to take these sixths and I wanted to cut them into 12 pieces instead of 6 pieces, if I wanted to cut this thing into 12 instead of 6, I would have to cut each one of those in half. Yeah? Cut each one in half, and that would give me 12 pieces instead of 6. So how many 12ths would I have if I did that? Well, let's take a look. This sixth, I'm terrible at pronouncing that word. This sixth would be 1/12 and 1/12, right? There would be 2 twelfths there. If we're cutting it in half into 2 equal pieces, each one would be 1/12. We do that again here and again here. And how many twelfths do we have total? Well, I see 1, 2, 3, 4, 5, 6 twelfths, not 8. This one is not our correct answer. How about this 1/4 here? Yeah, I see 3/4 up here. But what would I need to do if instead of 4 pieces, I wanted to take that sort of green rectangle up there and I wanted to cut it again into 12 pieces, not 4? Well, I would have to take each one of these fourths and cut it into 3. Cut it into 3, cut it into 3, cut it into 3. Now, if you count, there are a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 equal pieces. And there's 1, 2, 3, 4, 5, 6, 7, 8, 9 of them shaded. This is 9 twelfths, not 8 twelfths, so also not our correct answer. Which means by default it's going to be C, but let's go ahead and take a look anyway. I really want to kind of hone in on this idea that fractions really match the multiplication and division we already know. I want to link it to the stuff we've been doing up to this point so it doesn't seem like such a massive step. If I wanted to take this this pink and white rectangle here, and I wanted to cut it into 12 pieces instead of 3, how much would I have to segment each one into? Well, I'd have to cut each one into fourths. Boom, boom, boom. There's 1, 2, 3, 4 there. Boom, boom, boom. Now, once again, if you count, there are 12 equal pieces, and 8 of them, yes, 1, 2, 3, 4, 5, 6, 7, 8, are shaded. So this fraction, 2/3, right? There's 2 of them and they're each a third. This fraction 2/3 is equivalent to 8 over 12. Finally, complete the equation. 2/3 equals x over 9. See, we're already in 4th grade. We're already talking a little bit about variables, and this is a proportion equation. You will see these again in middle school and high school. We're not interested in the math of normalizing the denominator or cross multiplying or fraction busters or anything like that. Right now, we're just turning it into this nice colorful visual so that folks can see it. But hopefully this means that later on down the line, when they're 11, 12, 13, 14 years old and they're seeing these proportion equations, they can think, oh yeah, these are the same things I've been working on from the very beginning. This isn't different from the colored rectangles that were cut into pieces. It's the same process. Maybe that'll help it be a little bit less scary. I don't know. So in this case, I see we've got 2/3 highlighted here. And within that, there we go. Within that, I see 1, 2, 3, 4, 5, 6 ninths. So 2 over 3 is the same thing as 6 over 9. Now, at this point, I'd like you to kind of think about the things that we've been doing and the answers that we've been coming to, and how we might be able to streamline this process a little bit. Because later on down the line, we're not going to want to have to make rectangles and cut them into equal pieces in order to do calculations with fractions. So while we are doing this, it's on us to sort of try to notice the patterns that are coming up as we look at these shapes and how we might be able to generalize when we don't have shapes in front of us to look at. And that is equivalent fractions, fraction models. We are off to an excellent start. Let's move on.